All right, we're here. We got a 2000 GMC Yukon. It's me, Richard.
It's me, Charlie.
Yes, and so now we're gonna go through the fuel injectors and the entire fuel system.
All right.
This has actually been LS swapped. It's got a 6.0 truck motor and with Trailblazer SS intake and injectors. So we're gonna have to use those specifications for this specific engine. But locations will be used for a 2000 GMC Yukon Denali. All right, so we've now are under the vehicle. This is the driver front tire. So you can see the exhaust. And then there is our fuel filter out of a C5 Corvette. You can see the fittings coming in, and it comes up to the engine, up to our injectors, to our fuel rails. And there you can see it goes back down through these fittings right here. And then into the tank. It goes above, and our fuel pump is in the tank, and so we will not be able to access it unless you drop the tank, and that's the only way to get to that. And so that's that. So to recap, we have fuel from the tank, from the filter down here, comes in up to this rail right up here on the driver's side, comes up to the rail fitting right back here, crosses into here, then goes across over top the intake manifold down to the other side of the system. So yeah, that's it. All right, so now we've hooked into our test point right here, and then we are checking our pressure about right on the dot at 50 PSI. We're about there. And so that's just our regular priming for our idle that we're gonna start up. And so, yeah. All right, here's our idling duty cycle. So you can see they all have the same. So now we're gonna rev it to see if the frequency will change at all. Yep. Brought the frequency in, but all the stay on the same side. And as we go back down, our frequency displaces for our lower idle, but yet our duty cycle still remains the same. All right, so now we have put in our pico on the actual injector, and you can see our tiny duty cycles. And when the actual magnetic field collapses, it jumps all the way up to 60 volts. So we had to put ourselves a 20-to-1 attenuator to keep from damaging our picoscopes. So this is actually our range right here. And so let's zoom in on a little bit of one. No, the other way. And you can see the actual seal pop up. And you can see our duty cycle right about there, 445. And this is about 5 millisecond gap. So it's only on for about 5 milliseconds right there. So let's go ahead and rev it, and let's see how that changed. So I'm gonna run it, and we're gonna see it revving. Let's see if that duty cycle will change. So it's still going on for about 5 milliseconds. I just think it changes the frequency of the actual running engine. So yeah. All right, so now we're going to cover fuel injectors and what's inside them. So inside a fuel injector, you have a copper winding, a permanent magnet, and this kind of iron ball that is actually being pulled up and down. So that's what actually is pretty much causing that thing to open. So what happens is you've got a positive and negative side, so you've got power always flowing to it. So when your PCM grounds that negative side, it allows power to flow through this coil, and it puts a magnetic field within that winding. And to kind of help boost the strength of that magnetic field, we put a permanent magnet inside the windings, and then within that permanent magnet we keep this iron ball, and the iron ball is just the tip. The whole thing is iron or any ferrous material, and so that's kind of what goes up and down. So when we don't have power to it, and PCM is not grounding that, the iron ball is pressed by a spring. So right about here, there's a spring that will apply downward pressure, keeping this ball closed and sealed on the bottom of the injector. And then that way fuel cannot come around it, because our fuel is right here around the edge. And so then it's got about 50 psi, and so when we ground it, our permanent magnet and our windings will pull up on this iron or ferrous material, pulling it up, and fuel will be injected. And this can be done very, very quickly in very rapid success. And that's pretty much how a fuel injector works. So we talked a little bit about what is a returnless system. So a returnless fuel system means that the fuel doesn't return back to the tank. So we actually have our fuel tank right here. And so fuel, you have internal pump right here. We'll label it P right there. Then we have actually our regulator. Instead of it being up at our injectors, some of them, this one, our regulator is right here. Right outside the pump. So this is gonna be R. And it actually returns fuel back into the tank right there. So our pressure is then circulated within there. So all the external pressure comes up, and then we'll go to our fuel rail with our 1, 2, 3, 4, 5, 6, 7, 8 injectors. So these are our injectors and our fuel rail that we just saw up there. And so at pressure, you can be measured here and here at the fuel rail like you saw, but you notice how it doesn't, any external fuel doesn't go back to the actual tank. So there's some pros and there's some cons to that. That being, temperature of the fuel is going to remain lower temperature inside the tank, which is good. But let's say you've got your fuel up here at your injectors, is going to actually be heating your injectors, because your injectors are hot from the intake manifold and being inside your engine bay. So that fuel is going to also get hot and change your density of that fuel, and kind of making it want to, when it shoots out differently, it's going to have a different pressure. And so there's some pros and cons to that. So this is a returnless fuel system.